Okay, thank you for listening to this talk. I'm going to talk about our latest work. We're trying to use the emissivity temporal variation from 10 satellites to estimate the daily rainfall accumulation. My name is Yalei Yu from University of Maryland. I would like to thank my collaborator, Jill, Krista, and Sarah. In the past several years, we have been working on a concept of adding a time dimension into the retrieval process by linking several satellites together, especially in the GPM satellite constellation. By doing so, we have several applications. For each application, we have publications. Today, I'm going to highlight our recent work from the emissivity temporal variation perspective. The idea is trying to link 10 satellites from here, GMI, to AMSR 2, basically these 10 sensors together, trying to use the temporal variation as a low frequency channel. So right now, currently, there are two concepts for rainfall estimation. The first one, I call it hydrometer based. It links the ice scattering signature to the surface rain rate. This idea is particularly suitable for the frequencies at 89 and above. Actually, this kind of frequency is commonly available in the GPM radiometer constellation. Another concept is trying to use a soil moisture based uh, concept, which is when the surface gets wet, it's probably rained, especially in the large scale. As a large scale, for example, 10 or 15 kilometers, when surface got wet, we know it's highly likely it has been rained. So the frequency at less than 89 gigahertz is suitable for this kind of application. So for this for this project, we primarily use channels from these sensors from 19 to 37 gigahertz, which are commonly available in the GPM constellation radiometers. Of course, we would like to, in the future, we would like to combine it with Simmer, which also have 19 and 37 gigahertz. Here, I would like to emphasize that this is not a full set of the frequencies. Of course, we have some sensors, we have even lower than 19. Clearly, Simmer, also GMI, Amster 2, clearly, we can also extend this concept to lower frequencies. So here's the definition of the emissivity temporal variation. From the low frequency 1923 and 37, we compute the daily average emissivity for each grid box, a quarter grid grid box, quarter degree grid box. We compute the emissivity um, on a certain day, which has rainfall, and we find a clear sky background in the preceding observations. Uh, as I mentioned previously, we are using 10 satellites. Here is a local, this picture shows the local equator crossing time from a non-sun synchronous satellite. Of course, GPM is a non-sun synchronous. Basically means it can overpass a location at any time. So we design 4 different experiment based on the local equator crossing time and the imager and sounder, or you could say conical or cross-track scanning sensors. The first experiment, we only use GMI. The second one, we pick up 5 imagers. The third one is we pick up 6 satellites. We select 6 satellites, but we intentionally make sure these 6 satellites with very different crossing time. By doing so, we can capture the emissivity diurnal variation. The last one is the 10 satellite. We use all the 10 satellite. SIMRA, the local equator crossing time for SIMRA is around 9 o'clock. So clearly, it will be very beneficial to include the SIMRA in this concept because first, it's a imager. Second, it has excuse me, it has a better resolution. So here's result. As you can see, if we only use GMI, the retrieval is rather poor. Oh, I should mention that for all these 4 panels, the x-axis is emerge, the y-axis is retrieved. If we only use GMI, the result is not is actually pretty poor. If we use 5 emitters, we improve a lot compared with GMI only. As I mentioned, if we use 6 satellites with very different local crossing time, we can improve further compared with the 5 emitter. Of course, if we use 10 satellites, we improve a little bit compared with the 6 satellite scheme. The takeaway message, take-home message is that the more satellites we have better chance to find clear sky background in the short time. Also, we can better capture the emissivity dynamic cycle using more satellites. In this concept, we look forward to use a similar observation to further increase the observation frequency, and then we expect by adding similar observation, we can further improve our retrieval performance. I will be happy to address any questions. You can email me. Thank you.